Hey guys, we're going to continue these unusual ACT math questions, reviewing them with you. I've selected these particular questions off the April 2019 exam. And those questions were selected because many of the students that I personally train as a group seem to miss these the most, and they needed the most help with them. So I'm hoping that if you're using this particular exam to study by, you may have questions about these particular questions. One other thing, the purpose of me doing this is in hopes of reaching young adults who don't have any means to have help with training for the ACT. And it's important that you like, you share, and you subscribe to the channel so that we can reach those particular young adults. Now, with that being said, let's move right on. Question number 1. Okay, so question number 1 starts off with two matrices, A and B here, and it says, which of the following is the matrices of A minus B? All right, if you have a calculator, you could put this into your calculator and let it do the calculation for you. But if you don't, let me show you the longhand version of this. It's pretty simple. It's really not that hard. Let me just rewrite the matrices here. So 3, -2, -5, and 9. We're going to subtract them. -7, 4, 6, 5. Now, it's just like doing subtraction. We're going to pair the 3 with the -7, the -5 with the 6, the -2 with the 4, and the 9 with the 5. So we're going to say, first thing we're going to say is 3 minus 7. That's a -7, so that's going to become 3 plus 7. That's going to give us 10. So we want to keep our eye on that number. The next one we want to do is -5 and 6. So -5 minus 6. So that's going to be equal to -11. I'm going to underline that number. Now we're going to do -2 minus 4. So -2 minus 4 is -6. And then we're going to use 9 minus 5. And that's going to be 4. Okay. Now, we've got a matrices here. We've got a 10. We've got a 6. We've got a -11. And we got a 4. Now, which one of these matches our answer choices over there? 10, -11, -6, and 4, which is answer choice K. All right, let's move on to the next one. So this one we have a proportion actually. 3x minus y over x plus y is equal to 4/7. What is the value of x divided by y? Well, okay, we're going to treat it like a proportion. So let's start here. 3x minus y over x plus y is equal to 4/7. Well, we're going to cross multiply. We're going to say 7 times 3x minus y is equal to 4 times x plus y. Okay, now let's do the math, the mechanics of the math. 7 times 3 is going to be 21x. 7 times -y is -7y. 4 times x is 4x. 4 times y is 4y. Now we're trying to get this thing to where it's going to give us x over y. So we want to play with our common terms and get it to where it gives us x over y. So the next thing we want to do is get all our x's and y's together. So 21x minus 4x is equal to 7y plus 4y. Well, 21 minus 4 is going to be 17x. 7 and 4 is 11y. Now remember, we want to get x over y. So the next step, we want to do is we want to divide by y. And that's going to give me 17x over y is equal to 11. Now I need to get my 17 associated on the right side. So we're going to divide by 17, and we're going to have x over y is equal to 11 divided by 17. So therefore, that's going to give us answer choice H. All right, let's move on to the next question. So this is a vector graph. And I think what I'm going to do is just write on the picture here. So let me change my pen colors. I'm going to change that to red. Now it says the vector u, v, and w are represented in the standard coordinate plane. In what general direction will the vector u minus v plus w point? All right, so I'm going to draw on the picture. So our u vector is right here. So we're going to say u minus v. Now v, if you look at v, it's going in the positive. It's going in the positive sloped direction in quadrant 1. So therefore, if we're going to minus v, we're going to go the opposite direction and go negative. So we're going to go down. So there's our minus v. Now it says plus w. Well, w originally goes, it stays right on the x-axis, the positive x-axis, heading towards the end of the graph. So we're going to draw the same vector in the same direction. W. So there's w. Now look at your answer choices. U goes up, V comes down, and W to the right. So up and to the right. Answer choice A. Okay, let me change my pen tip back. Next question. So we have two functions, and it wants to know f of g of x. We know f of x is equal to x squared plus 2, and we know g of x is equal to x plus 3. Now we want f of g of x. So we've got to take g of x and put into f of x. So we're going to take x plus 3, and we're going to put it into the x in f of x. So x plus 3, we want to square that because f of x is squaring the x. Now we're going to add 2. Now, x plus 3 squared, I'm going to put over here, means x plus 3 times x plus 3. do your mechanics of your math, and you're going to get x squared, x times 3x, and then 3 times x, 3x, and then 3 times 3 is 9. Clean up your math, x squared plus 6x plus 9. So the x plus 3 squared is x squared plus 6x plus 9, and then we're going to add 2. Well, 9 and 2 is 11. So we're going to get x squared plus 6x plus 11. Now, that becomes answer choice H. All right, let's roll on. Okay, so we've got trapezoid here, and it tells us the base lengths of isosceles trapezoid, ABCD, shown below are in centimeters, and E is on AB. What is the ratio of the area of ABCD to the area of triangle AED? Okay. Now, what I want you to notice in this image, let me get my red pen. Notice there's a triangle, which is AED, but there's also one over here as well. And notice from D to C, the distance is 40. And notice the distance from A to B is 60. If we remove the 40, so if we take our 60 and remove the 40, we have 20 left over. That 20 is split between two right triangles. So you can divide that 20 by 2. And we know the bases of our triangles are both 10. So we know that triangle base is 10 here, and then 10 here. Okay. Now we can finish the problem. We can figure out the area of the triangle. I'm going to put A sub t. That's 1/2 base times height, right? All right. So we know the base is going to be 10. So 1/2 10 times h. So that's equal to 10 halves times h. Or it reduces to 10 divided by 2, 5h. That's the area of the triangle. Now the trapezoid, I'm going to just write it under the picture, is going to be the 40, the side with the 40 DC, plus AB, which is 60, divided by 2, times the height. 40 plus 60 is 100. Divide that by 2 is 50 times h, 50h. All right, now it says, what is the ratio of the area ABCD, which is your trapezoid, to the area of triangle AED? So 50h over 5h. That's the ratio. Your h's cancel, and your fraction can be reduced to 10 over 1. So therefore, the ratio is 10 to 1, which is answer choice D. Okay, let's move on. logarithm, what is the value of, what real value of x satisfies the equation? So here's our equation. It is log base 5 of 25. I got this squared is equal to 2 times x. Okay. So what we're going to do, the opposite of logarithms is exponentials. So we're going to create, we're going to convert our exponential, our logarithm into an exponential. So we're going to say base 5, because it says log base 5, base 5 raised to the 2x power is equal to 25 squared. Okay, so I need to rewrite 25 as 5 squared so I can get it into the base 5. Now I have my exponentials in base 5. So therefore, I can pull out my powers. And 2 raised to the second power is going to give us a 4, right? So that's going to be 5 to the 4th. 5 to the 2x. So 2x is equal to 4. Now, x is going to be equal to 4 divided by 2, which is going to be 2. Therefore, answer choice F. The key thing here is to get your bases in the same power. It's really important when you're working with exponentials, and especially on the ACT. They love to make you make that conversion that way. All righty, let's move to the next one. Got a few more and we'll be done. So here we've got a square with an interesting shaded region. But notice each corner of the square is a portion of a circle. So it's a quarter of a circle. And it says, what is the area in square feet of the shaded region? So the idea here is to take the square's area of the square, and subtract out the area of the circle. That's the idea. Okay. What do we know about this? It says in the figure below, points E, F, G, and H are on the sides of the square. All right. A, B, C, D. Arc EH has a center at A. Arc EF at B, arc FG at C, and arc GH at D. All of the arcs have a radius of 3 feet. So we know we have a radius of 3 feet. So radius is equal to 3 feet. Now, that means, let me get my red pen. That means C to F is 3 and 3. And then D to G is 3 and then 3. That's your radius all the way around. Okay. Now we know because of that, the square's side length is a total of 6. So we got some extra information out of the figure. Let me switch back to my white pen. So the area of a square is just the side squared. So the length of the side of the square is 6. That's 6 squared, or 36. Now the area of the circle, the formula for the area of the circle is pi r squared. You know the radius is 3. So that's going to be pi 3 squared. 3 squared is 9. So you have 9 pi. Now, notice when you look at your answer choices, they don't give you single digit numbers. They're asking you for the expression. So our expression is 36 minus 9 pi, which is answer choice E. Okay, this question sometimes really isn't fair to students. And this question is dependent on you either having a really strong Algebra 2 class, or you are currently in a pre-cal class where you've been forced to memorize some identities. Some identities that are really important are these that I'm going to write down for you. So the sine of x is equal to 1 over the cosine. Cosecant of x is equal to 1 over the sine of x. And then the cotangent is equal to 1 over tangent of x. Okay. Those 3 are important. I'm going to write 3 more down here that are important. The cosine of x is equal to 1 over the secant. And then the secant of x is equal to 1 over the cosine of x. And then the tangent of x, I'm going to put it right here. Tangent of x is equal to 1 over the cotangent. These 6 identities are going to be really important. Now I'm going to give you 2 more. I'm going to write them in the right-hand corner because we're going to need the rest of the space to write. So the tangent is also equal to the sine divided by the cosine. And you can get the cotangent by flipping that and saying cosine over the sine. These identities you will learn in your pre-cal class. I don't recall them being given to you in Algebra 2 unless it's really an advanced Algebra 2 class. Okay, so look at F. F says, well, first of all, the question says for all real values of x, where x is between 0 and pi halves, which of the following expressions is not equivalent to tangent of x? Okay, so 1 over the cotangent. 1 over cotangent, if we look over here at our formulas, that's the tangent of x. So F works out to being the tangent of x. So it's not F. Okay, G says the secant over the cosecant. Now let's see, did I put that one over here for you? Secant over cosecant, did I put that one here for you? No, so I'll work this out for you. So the secant over the cosecant. So you know the secant is 1 over the cosine. So let me write this down here. 1 over the cosine divided by the cosecant. And the cosecant is 1 over the sine. Now you divide by a fraction, so you multiply by the inverse. So that's going to give us sine over cosine. Now the sine over cosine is equal to the tangent. So it's not G. All right, H, we have sine over cosine. Well, we just figured out sine over cosine is a tangent. So H is equal to the tangent. So it's not H. J, okay, cosine over the cosine times the cosecant. So the cosine can be I'll work this out for you. So cosine, and then the cosecant is 1 over the sine times 1 over the sine. So that gives you cosine over sine. And cosine over sine gives us cotangent. Now, we just found that J gives us cotangent. So therefore, that's not equal to the tangent. Therefore, our answer is J. Now, using these formulas that I gave you here, you can work these out. The sine times the secant is just, I'll work it out for you. So the sine times the secant over here for K, I put K here. So you'd have the sine, the secant is, let's see, 1 over cosine. So that's going to be sine times 1 over the cosine. That's the same thing as saying sine over the cosine. And the sine over the cosine gives us the tangent. So our answer choice again is J. Now you can use these identities that I gave you to help you work through problems like this. With this being said, there aren't many questions on the ACT that you will ever be faced with like this. They occur very infrequently. So it's not frequent that you see a question like this. All right, let's get to the next question, and then we'll be through. All right. Our lovely, lovely ellipse. Okay. Shown below is a quadrilateral ABCD. It's inside the ellipse. Now, the figure will be placed in the standard coordinate plane. So we're going to put it in a coordinate plane. So we're going to have a coordinate plane. Y-axis, x-axis. And the ellipse will be described by the equation x squared over 9 plus y minus 5 squared over 16 is equal to 1. Okay, given that line AC is the minor axis and BD is the major axis, so the ellipse is going to be around the y-axis, stretched out around the y-axis. The width of the ellipse is going to be among the x-axis. Given that AC is the minor and BD is the major, what will be the coordinate points of A and B? Okay. It's important to understand that where the ellipse is centered at. So the numerator of the equation, x squared over 9 plus y minus 5 squared over 16 equal to 1. The numerator tells us where, the numerator refers to the circle portion of the ellipse. The numerator is going to tell us where the center of the circle will be. Now, remember the equation x minus h squared plus y minus k squared is equal to r squared. That's what they have in the numerator of this equation. So there's no h value with the x. So therefore, that means the x value is 0. So we know that the point is going to be 0. The k value here is a 5. So therefore, the center is going to occur at 0, 5. Let me put some marks on these number lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll make that 10 there. 1, 2, 3, 4, 5. There's our 5. So right here, 0, 5 is going to be the center. Now let me put some marks over here on the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do the same thing down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then put 10 over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right there. Okay. Now, we found the center of the ellipse. The denominator of the ellipse equation gives us information about the ellipse. Notice that the 16 is the largest number, and 9 is a smaller number. The 16 is associated with the y portion of the equation. So therefore, if we take the square root of 16, we get 4. Now, if we count from the center of the circle up 4, you get to number 9. So right there, 0, 9. Sorry. Now, if we come down 4 from the center, we get to number 1. So that's going to be 0, 1. I'm going to put it over, well, where can I put it? I'll just put it right here, 0, 1. Okay. Now we're going to use the square root of 9 to figure out the width of the ellipse. The square root of 16 was to figure out how long it stretches out. So we'll call that the length of it. So the square root of 9 is equal to 3, right? So we want to go over 3 to the right from the center. So that'll give us 5, 3, right about there. That'll be 0.53. And then we're going to do the same thing over here. Oh, sorry, I messed that up, didn't I? Let me erase that. Let me fix that. That's going to be 3, 5. All right, now we want to go 3 to the left. So that's going to give us a point here and at 5. So -3, 5. Now what we can do is just kind of sketch an ellipse, connecting these points right here. This isn't going to be perfect, but it's going to give you a good idea. All right. Now, the question says, given that AC is the minor and BD is the major, what will be the coordinates of point A and B? Well, here's point A, And then here's point B, which is up here. So A is -3, 5. A is equal to -3, 5. And then B is equal to 0, 9. Now, which one of these have our points? That's going to be answer choice J. Okay, guys, that's quite a bit for you to be familiar with. Some of you get ellipses in your Algebra 2 class, or maybe you've seen it in geometry, but you will see it in pre-cal. Well, the interesting thing so far, I haven't seen any ellipses since 2019. Yeah, 2019, end of 2019, before the pandemic started. But please make sure you understand what I've just put up here for you. Now, with that in mind, I wish you all the best in your studies for your ACT. I don't know when you're going to be taking it, but make sure you got a good plan. Make sure you're studying all the time, all the way until test day. And I wish you all the best. And if I ever can be of help to you, please, our contact information is below. There's links to the webpage that has my email address. Use it. I don't mind answering questions. With that being said, all the best, guys. And one more thing, please remember to like and share and subscribe, because I'm trying to reach these young adults that don't have anyone to rely on for help. Have a great day.